Hello everyone, welcome back to the class. Today, this is Professor Amit Brambhat and I'm teaching CSC 208 for Laurel Ridge Community College. Today we are going to look at conditional execution. Up to this point, our program has behaved like trains on a single track, executing one line after another from top to bottom. Today, we are going to learn how to build hooks in the track. We'll teach our programs how to make choices, ask questions, handle unexpected errors, and execute different blocks of code based on dynamic runtime parameters. Let's dive in. So at the heart of the conditional execution is George Boole's logical legacy. Boolean expressions. A Boolean expression simply asks a question that evaluates to either true or false. Python uses comparison operators to inspect variable states without changing the data itself. By evaluating these conditions, our programs can dynamically choose which path of instructions to run next. This logical branching is a foundational programming pattern that you will use continuously, especially when we start packaging logic inside reusable functions blocks in the next chapter. Now, this slide, we look at the comparison operators. So first one is less than, then we have less than equals, then we have equal equals, then we have greater than equals, then we have greater than, and the last one is not equals. The two equal signs is the equal operator. This is a major source of syntax errors for beginners. Remember, a single equal sign is for assignment. It changes memory state. A double equal sign is a query. It asks a question without changing any values. Keep this distinction clear in your mind as you write the code. A one-way decision is the simplest fork in the road. We use the if statement if the condition evaluates to true. Python executes the intended block immediately following it. If the condition is false, the compiler completely ignores the indented block and skips to the next unindented statement. In the code example on this slide, if x is 5, x less than 10 is true, so smaller prints. But if x is greater than 20, it's false, and so bigger is ignored, and the program moves directly to printing finis. Indent. Strict indentation syntax. In many programming languages, code blocks are grouped using only curly braces. In Python, we use indentation. Indentation is not optional. It's a code compiler rule. After an if statement ending with a colon, if you must increase your indent by exactly 4 spaces or a tab. This tells Python which statement belongs to inside the conditional block. Once you reduce that indentation back to original margin, you signal Python that the conditional block has ended. Keep your indents perfectly aligned to avoid indentation errors. Now that we understand one-way decisions and the absolute importance of clean indentation, let's look at how we control more complex execution pathways. We explore two-way forks, multi-way selectors, and nested decisions, and how to protect our code from runtime crashes. Let's look at the two-way decisions. A two-way decision is like a true fork in the road. You must choose one path or the other, but you cannot choose both. In Python, we write this using if and else. If the primary condition is true, the if block executes and the else block is skipped. If the condition is false, the if block is skipped and the else block runs. This ensures that your program always has a safe, defined execution route regardless of the logical outcome. For more complex scenarios where you have multiple possible outcomes, we use multi-way branching. The lifecycle works as a top-down evaluation pipeline. First, Python checks if the primary if condition, if that is false, it scans down the road through any subsequent elif or else if clauses. The first matching true condition executes its block immediately. Once a match is found, Python runs that block, skips all remaining clauses, and jumps directly to the rest of the program. It's a highly efficient one-match execution guarantee. Let's look at multi-way example. If x is 20, Python checks the first condition x less than 2. This is false, so it moves to x less than 10. That is also false, so it drops into the default else clause and prints large. Remember, even if multiple elif statements could theoretically evaluate to true, Python only executes the first one that matches and completely ignores the rest of the chain. Keep this order of evaluation in mind when designing your conditional logic. To understand why efficiency matters, let's look at the hardware. Your conditional Python code lives inside your computer's high-speed, volatile main memory or your RAM. The CPU consistently fetches these instructions, evaluating logical branches using high-speed internal registers. This is a continuous loop of execution. Writing clean, non-redundant conditional statements helps maximize CPU cycles and prevents software bottlenecks, especially at your program's scales in size. The try except safety net. Finally, let's talk about safety. When your code encounters an error, like trying to cast user text to an integer, it crashes, raising a trace block error. To prevent this, we use try except structure. You wrap any dangerous line of code inside a try block. If it works, the except block is skipped. If it fails, Python jumps straight into the except block, executing your backup code instead of crashing. This is your primary shield for building highly resilient, user-proof software. We covered comparison operators, indentation rules, two-way and multi-way decisions, try except safety nets today. If you have any questions, please send me an email and I'll try to respond to you as soon as I can. And yeah, let's call it a class. See you in the next one.